Today, we're diving into a topic that's not just crucial but can make or break your software. Unit testing in Spring Boot with the powerful Mockito Framework. I know, some of you might be thinking, why bother with unit tests? My code works fine. Well, buckle up, because we're about to embark on a journey that will not only answer this question, but will revolutionize the way you approach building robust and reliable software. But before we jump into the nitty-gritty of unit testing, let me paint a scenario. You've built this incredible Spring Boot application, right? It's got all the bells and whistles, interacting with various services, databases, and whatnot. Now imagine you make a small change, a tiny tweak in one part of code. Everything seems fine on the surface until suddenly your application decides to throw a tantrum in production. Chaos, panic, and a barrage of angry users. Not the scenarios you want, right? So this is where our superhero comes into play. Unit testing. And our sidekick, Mockito, is here to save the day by helping us create a controlled environment for our tests. Ever wondered why we need to mock services? Stick around, you'll discover the pivotal role it plays in ensuring your tests are reliable, isolated, and effective. We're not just writing tests for the sake of it, we're building a safety net around our code. With each test, we gain confidence that our application behaves as expected, even when we make changes, and trust me, in the fast-paced of Word software development, that confidence is really gold. Now, join me on this journey to demystify unit testing, explore the wonders of Spring Boot, and unravel the secrets of Mockito. Together, we'll empower you to write code that not only works, but stands resilient against the wind of changes. Buckle up, hit the subscribe button, smash the like button, and help me grow this channel and spread the knowledge everywhere. And let's dive into the fascinating world of unit testing in Spring Boot with Mockito. Ready? Let's roll. Implementing tests for a Spring Boot application is important for several reasons. First, we talk about quality assurance. So tests help ensure that your application functions as expected. They identify bugs, error, and expected behavior early in the development process, allowing you to fix issues before they reach production. And then regression testing. As you make changes or add new features to your application, tests act as a safety net to catch regressions. They ensure that existing functionality continues to work as intended even after code changes. Also, test serves as documentation for your code base. They provide examples of how your code should be used and demonstrate its expected behavior. This is especially helpful for other developers who may join the project later on. Also, well-written tests encourage good coding practices and modular design. They often lead to the more modular, loosely coupled code that is easier to maintain and refactor. When you want to refactor or optimize your code, tests provide a safety net. They allow you to make changes with the confidence that you'll immediately know if something breaks. Also, the tests facilitate collaboration among developers. When multiple team members are working on the same code base, tests ensure that changes made by one developer don't negatively impact the work of others. Also, in a CI/CD pipeline, or like continuous integration, continuous deployment pipeline, tests are run automatically whenever new code is pushed. This helps catch issues early in the development process and prevents faulty code from reaching production. Also, written tests can take more time upfront, but it can significantly reduce the time spent on debugging later in the development process. It's much easier to identify the root cause of a failure when you have a well-defined tests. As your application grows, the complexity also increases. Tests provide a safety net that allows you to confidently make changes and add features without introducing unexpected issues. And finally, of course, certain types of tests like security and vulnerability tests help identify potential security weaknesses in your application. This is crucial for protecting sensitive data and ensuring the overall security of your application. So generally speaking, in a Spring Boot application, you can implement various types of tests, including unit tests, integration tests, and even end-to-end tests. So each type of test focuses on a specific aspect of your application's functionality and provides a comprehensive safety net to ensure its reliability and correctness. Now let's see how Spring can help us in implementing the tests and what Spring provides exactly. So first, Spring provides utilities and annotations for testing applications. So the test support is provided by two modules. The Spring Boot test contains core items, and the Spring Boot test auto-configure supports auto-configuration for testing. And then we have also the Spring Boot starter tests, which imports the following modules. First of all, we have the Spring Boot test module. We have also JUnit, AssertJ, Hamcrest, and number of other useful libraries. So a Spring Boot application is a Spring application context, and this I will explain it more in details when we go to the practice part. So the Spring Boot provides a Spring Boot test annotation when you need Spring Boot features during tests. So for example, if you want to load the application context in your tests, all you need to do is to annotate your class with the Spring Boot test annotation. And then in case you are using JUnit 4, you need to add the annotation run with spring runner.class to your test, otherwise the annotation will be ignored. Other than that, if you are using JUnit 5, there is no need to add the equivalent extend with Spring extension, as the Spring Boot test annotation and the other annotations will be already annotated within the @Spring Boot test. So now we mentioned that Spring comes with a Spring test auto configuration module. So the Spring Boot's auto configuration system works well for applications, but can sometimes be a little too much for tests. So it often helps to load only the parts of the configuration that are required to test a slice of your application. So the Spring Boot test auto configure module includes a number of annotations that can be used to automatically configure such slices. And finally, each slice restricts component scan to appropriate component and loads a very restricted set of auto configuration classes. Now we are done with the theoretic part. This might be a little bit too much or like too much talking. Now we will move to the practice part, and you will be able to understand and start implementing tests your own. So let's move on and let's go ahead and do it. All right, now let's dive into the implementation of tests for our different classes. So here, this is the diagram or the composition or the class diagram of our small application, and I'm focusing only on the student domain. So here we see from the bottom to the top, we have the student composed of the student service. This means that the student controller uses the student service, and the student service use both of student repository and student mapper, and the student mapper will use both object student and student response DTO. So now I want to tell you and explain to you what you need to implement test for. So what do you need to test, which classes and which objects you need to implement tests for. So here we see that the student response DTO and the student object, they are just classes. So there is no logic inside it. So it's just a class holding some information about the student, and this class or this record is only holding some information about the student response DTO. Now, if we go a level down, we see that we have the student mapper And then we have the student repository. So the student repository, we can also implement tests for that, but it doesn't make sense, or it's not really required to implement tests for repository. So we will skip this one. Now let's start with the student mapper. So the student mapper right here. So if we go to the navigation, or if we navigate to the student mapper right here to this class, we see that we have two methods. All right. So now I want you to change a little bit your mindset and suppose that you don't know the code before. So you just have a mission, or you're asked just to implement tests for these classes. So here we have two methods, toStudent and toStudentResponse.DTO. So the first one will return a student object, and the second one will return a student response DTO. So normally from the name of the method, we can understand what is its functionality. Otherwise, we can go ahead and read the code. So we don't need that because we already implemented this our own. And now what we need to do is to create a test class for this student mapper. So to create a student mapper test class, let's start with the recommendation. So here we see that we have the Java, and this is the base package that we have, which is com.alibu.example. And then we have school and student profile and so on and so forth. Here, if we check the test, we have also Java and then com.alibu.example. And here we have also example application test, which is the same, or like the same loader class, or the class that will load the application context for our test. So for now, we will just ignore this one, and I will explain it in the coming sections. All right, now the first recommendation is when you create a test class for one of the services or the classes that you want to test, be sure and make sure that you keep the same package naming. So you need to keep the same hierarchy of packages and folders, just to make it easy to find. So you can just create it anywhere, or like even without creating packages, but the recommendation to make your test classes clean and clear and easy to understand and easy to point, you just need to keep the same hierarchy, or like the same package hierarchy. And we are lucky because our IDE, whether you are using IntelliJ, Eclipse, NetBeans, and so on and so forth, you always have some shortcuts, and you have the instruction and menu to generate test classes for the class that you want to test. So here, if I open back my test student, or like my student mapper class, and I want to generate a test class for it. So if I do like right click, and then let's click on generate right here. So here we see that we have many options, and among these options we have test. So if I click on test, you will see that it will be generating a student mapper, and then it will have, or it will give it a suffix called test. All right. And here you see the destination package. It will be com.alibu.example.student. You can select a different one, or you can change the name and so on and so forth. But as I mentioned before, I recommend you keep the same hierarchy. And then you also can generate methods for setup, teardown, or also showing the inherited methods. And even you can generate two methods, or like two test methods for the toStudent and toStudentResponse.DTO. But for now, we won't do that. We will do it one by one and step by step. So I will cancel. Then we have a different option. So here, just focus on this area. You will have this green pop-up to show you which command or which shortcut or keyboard shortcut that I will be using in order to navigate to the test. So here, if you do Command Shift T or Control plus Shift plus T if you are using Windows or Mac, IntelliJ will try automatically to navigate you to the test class of this student mapper. All right, but if it can't find any test class, it will suggest you to create a new one. So it will also open and display the same window that we used before, or that we saw together before. And here for the testing library, since we are using Java, like recent version of Java and also like a recent version of Spring Boot, so we can keep, or we can use the JUnit 5. Also, if you have another project using JUnit 4, for example, I already explained that before, that you need to add few annotations, or like one annotation, in order to make it work. So now all we need to do is to click on OK button, and here you see that automatically a new package was created, and it contains a new or student mapper class test. Alright, so now we have everything ready. Let's go ahead and start implementing, or let's start writing the first test method that we have for our student mapper class. Alright, so first of all, let's generate a first test method. To create a test method, all you need to do is to create a public void. So this is the signature, and it should be always public void, and then the method name. So let's call it test method 1. So this will be the first test method, and the test method is a method without any parameters. So here, to make this test method as a test method, so all we need to do is to add the annotation test. So the test, it comes from org.JUnit.jupyter.api. So here, once we add this test, you see automatically that now we have this button to run this single method, or you have this button right here to run all the test methods inside this class. So let's first of all just add a system.out.println, and here my first test method. And now let's run this test class using this play button to run only this method, since we have only one, or if we want, we can run the whole test. So let's run student mapper test class, and then you will see that it will open the test view, and here we have the system.out.println, the message that we printed, my first test method, and the test was green since we have nothing to assert yet. We will come to this in few moments. But before that, we need to understand what are the properties and what are the things that we can do within a test class. So the first thing that we need to know is that we have a setup method, or we can create a setup method. So if you click on generate, here you will see that you have a setup method. You can generate it automatically, or you can even write it your own. So let's generate it and see what is this method. So it's just a void called setup, and it contains an annotation called before each. So this means that this before each method, or this setup method, will be executed before each test that we have. And we mainly use this setup in order to initialize few things or few parameters, or anything that we want to initialize before running any test method that we have. So I will just copy this message right here, and here I will just write inside before each method. And now if I run again my class, let's see what will be the output. So here we have, if I click in here, we have inside the before each method and then my first test class. So now I will just duplicate this method right here, and I will call it my test method 2, and here I will say my second test method. Alright, so I will rerun again the class, and here we see that this one we have inside the before each method my first test, and here we have also inside the before each method and then my second test. So as I mentioned, this before each will be executed before each test class. So in case, as I mentioned before, in case we want to initialize anything before running the test method. Alright, so also as before each, we have other methods, and let's go ahead and explore them one by one in order to understand the structure of a test class and what are the usages and the benefits of using these methods. Alright, also if we want to execute any script, for example to reset the values of variables or classes or services or whatever, we also have a method, we call it teardown. So the teardown is after each execution of test method. So here, let's use the generate again, and here we see that we have the teardown method. So let's generate it, and here you see after each. So let's copy the same message, and here inside the after each method. When we run the test class, we will see inside before each method, and then my first test method, and finally inside the after each method. So let's go ahead and execute it and see the output of this execution. So now I'm going to select the first method, and as I mentioned, we see inside before each my first test, and then inside after each. So as I mentioned before, in case you want to reinitialize, or for example to change the value of a specific attribute, or for example, if you are running your tests against database, so you can just initialize and insert some data in the before each, and after each you can delete them or re-update the data in order to be able to use them in the next method. Alright, so now let's move on and let's see what are the other methods other than the before each and the after each. Alright, now the question is, what if I want to execute a setup or to initialize a few attributes and variables only before the execution of the whole class? So I don't want to run this method before each method, but I just want it to be executed only once. So in this case, we have also another method. So let's click on generate, and here we see we have a before class. So when I use a before class, so it's called a before all. Again, I will copy this message, and here I will say inside the before all method. So now when I run my test, so you can whether run it from here or again click on this play button or just run one of the tests. So let's go ahead and run and rerun the whole class and see what we have. So for example, let's select this one. So here we have first, when we select the method, we see only these three output messages, which is the before each, the method, and then the after all. But when I select the class, we see that we are inside the before all methods, and then inside the before each method and the after each method, and we have it again for the second method. So now just I want to make this output clear, so I will be running only one method, so like that you will see it in a better way. So now we see that we are inside the before all method, and then inside the before each, my first method, and then inside the after all method. So this is the case if I want to initialize something, a service for example, or to create a new instance of an instance or an array list or something like that, but I want to do it only one time. I don't want to do it each time. So in this case we use the before all method. So now in the same way we have another method called after all. So let's go ahead and try this one, and then let's move to the real implementation of the real test cases of our student mapper class. Alright, in the same way, let's generate an after class or an after all method, and again I will just copy paste and here inside the after all method. So if I run one of the test classes or the test methods that we have, and here let's go ahead and check the output. So here we have inside the before all, and then inside the after all, and in between we have the before each, the test method, and the after each. So the use case of the after all and the before all is, for example, I want to initialize or insert some data into my database in case we are using, for example, an in-memory database. So I want to insert some data, and then once I'm done, I want to remove them, for example, or even if I'm working against my dev environment database or something like that. So in this way, we can initialize data, work with them, and once we are done, we can remove all the data that we already inserted. So in this way, we are safe from polluting and inserting wrong data into our database. Alright, so now you know the structure of a test class. What are the methods that we can use within a test class? So now let's go ahead and start implementing few test cases for our student mapper class. Alright, now let's start implementing our tests. First of all, let's start by cleaning up all this code. So let's remove it, and also let's re-optimize the imports. And now let's implement the first method. So here, just to remind you, we have our student mapper class that performs a mapping. So it transforms a student DTO to a student object, and then we have to student response, and it transforms a student to a student response DTO. So now coming back to our student mapper test. So here the first thing that you need to do is to declare the service that you want to test. So here we want to test our student mapper. So let's create an object of type student mapper, and then let's call it mapper, for example. And then the first method, or like the first use case or the test case that we want to implement, is that we want to make sure that this toStudent mapper performs a correct mapping from student DTO to the student object. So here, let's create our first method, public void, and let's call it should map student DTO to student class. All right. So this is our first method, and to make it a test method, we need to add always the test annotation. So then you see that this student mapper right here is not yet instantiated. So we don't have an instance or an object of type student mapper. So here it's just the variable or the field. So now we have two options, whether to initialize it in here so we can do new student mapper, or we can use one of the test of the setup methods. So here we can add a before each, and then we can move this part right here to this setup method. So we can make it this way or the other way round. So let's go ahead with the before each. So now we have our mapper object initialized, and now let's start creating and implementing our first test method. So here, the first thing that we need to do, we need to create an object of type student DTO, since this is the input of our toStudent method. So now let's go ahead and do it. So here we have an object of type student DTO. Let's call it DTO equals new student DTO. And for this, let's call it John. And then for the last name, let's call it Doe. And we have an email, so john@mail.com, for example, and then we have an int the school ID. So in this way, so I'm gonna just inline this one. So in this way, we have our student object. So after that, all we need to do is to call this toStudent method. So here, let's create an object of type student, and let's call it student equals our mapper dot toStudent, and then we pass the student DTO, and then we will start asserting that the output of this mapping method is what we expect. So here, let's go back to this toStudent method, and we know that when we call this student method, we just set these fields, and then we have an object of type school. So again, we can test. So what we want to focus on is that we have also a mapping for this school object, and that we have all the fields not changed. So now let's first start by asserting. And in order to assert, so here we have assert equals, and this assert equals, so it comes from assertions. So the assertions is from the package org.JUnit.jupyter.api .assert equals, and here for the assert equals we have multiple implementations. So we can assert equals shorts, bytes, strings, integers, and so forth. So here let's do assert equals, and then what we want to test, we want to make sure that our DTO.get first name to be equals our student object.get first name. So here we want to make sure that this first name is the same for the class student. All right. So now also we can import statically this assert equals, and we can do that by add static import for JUnit Jupyter API assertions dot assert equals. So when we do that, and when we go up, so you will see right here that we have a static import for that method. So the next time you see assert equals or any static usage of a method, so you know that it's statically imported in here. All right, so now let's continue the assertion, and here we have the first name. Let's also test the last name, and here get last name, and after that we have the email, and also here get email. And finally, we want to make sure that the school is not null. So here, for example, we have the assert not null. So as you can see here, so I want to assert not null that my student dot get school is not null. All right. So then we can also make sure that the school ID was correctly set. So what I can do, we can assert equals. So our DTO dot school ID is the same as student dot get school dot get ID. So at this level, we are safe because we have an assertion that the school is not null. But if we change the order, we might encounter a null pointer exception in case the school is not correctly mapped. So now let's just go ahead and run this test method, and let me show you what is the impact and the execution of this method. So here we see that the method was green, but now you might ask the question, I'm just making sure that this object that I created manually is the same as I called this method. So now let's go to our student, and for example, let's say that I forgot to set the school to the student object. And now if I go back and rerun again the test, let's see what will happen. So here we have a test failed. So here we see that expected not null, but the object was null at this point. So here you see that assert not null of the school. So this means that the school was null and I'm expecting the school to be not null. So now step by step, you see the importance of having unit tests within our application. So let's go back to the mapper and let's bring this back. And then, for example, let's say when I transform the first name or the last name, I just do to uppercase. All right, so I transform the first name to an uppercase. If I rerun the test again, you will see that the test will fail. And here we see this message. So here we have assertion failed error, and the expected was John, which is the object right here that we initialized with our DTO, and the output was John with an uppercase. So this is also another or a different assertion level or an assertion test that we make sure that the input should be exactly the same as the expected output. All right, so now let's go back to our mapper and let's just remove this one. And in case, for example, you have changed the implementation of this toStudent method, you need also to update the test. Okay, so in this case, you make sure that everything works fine. So let's run the test one more time and make sure that everything works fine. So our test is green. Now we can move on and implement other tests. All right, so now since you know and you understood how to implement tests, so I want to give you a small exercise. I want you to implement the test method for testing these toStudent response DTO, and it should take a student object and then return a student response DTO. So you can also inspire and follow the same example we did right here. I want you to create another method and you call it should map student to student response DTO. So I will let you do it and I will provide you the correction in the next lecture. That's good. I was sure that you will implement it correctly. So let's do it together. All right, so first of all, we need to create a public void method, and then let's call it should map a student or student to student response DTO. All right, and then parentheses, and then the brackets, and don't forget the test annotation. All right, so the first thing, as we did before, we need to create an object of type student. All right, so here go student equals new student, and then let's initialize our student object. So here let's say Jane as a first name, and then Smith as a last name, and then let's provide an email, so jane@mail.com, and then we need an age, let's say for example it's 20, and let me inline this. All right, so now we have our student. Then all we need to do is to create an object of student response DTO, and let's call it response equals our mapper, and then to student response DTO, and we need to pass our student. All right, now comes the assertion part. So the first thing we need to do is to assert first name, last name, and email, and make sure that the result is the same, since within our student response DTO, we only have 3 attributes. All right, so now let's say assert equals, and then I want my response dot first name to be the same as my student dot get first name. The same for last name, so here last name, and then get last name. The same for the age. I want the age to be the same as the student.getAge. Sorry, we don't have an age for the response DTO, but it's email, and here it should be the same as get email. All right, so now let me add a few comments. So here, how we can read the test. So here we have given a student object, and then when we map the student to a student response DTO, then I want or I expect this result. So now let's go ahead and run the test and make sure that everything works fine and we did not forget anything. So the test is green. Also, let's go ahead and run the whole class. And here we have all the tests are green and passing. Okay, so that's it. Let's move on and let me talk to you about something really important when you implement an application, and mainly you can detect that with the tests. All right, now let me talk to you about something else. So here I will just start by creating a new test method. And after this method, I will just create a method called public void, and then this is also a different way of writing the method name, so we can write it in this way: should map student DTO to student object. All right, but this new method I want to add if, or let's make it when student DTO is null. So this means I want the mapping to be or to perform correctly or in an expected way, even if the student DTO that I'm passing right here is null. So what I will be doing, I will just copy this part right here and then paste it in this method. And instead of passing the DTO, I will pass a null object. So here, what I will be doing, let's say for example, so we will change this later on, but let's start expecting this. So here, let's say an empty string, and here an empty string. All right, now if I run this test method, let's make it a test. And if I run this test method, let's see what will happen. So here we have a null pointer exception cannot invoke the student DTO.first name because DTO is null. All right, and the exception happened inside the mapper itself. So if I click here, we see that the problem is exactly in here because we are trying to get the first name from a null object. And here we mainly talk about code coverage. So we need to cover all the use cases that our method and our service class and our class, generally speaking, should handle. So here you see and you noticed that we did not handle the case when we pass a null DTO object. So in this case, what we need to do, we need to go back to our student mapper, and then we need to add a test or a check or do whatever, just to make sure that when we receive a null object, we want to do something, whether raise an exception or just printing a message, or even, for example, initializing an empty student object with, for example, let's say empty values. So the implementation always depends on the requirements of your story or of the application that you are implementing. So now let's go ahead and start doing this. So in this case, or in this use case, we will see many things. So the first thing, let's go back to toStudent. And here I want to do if my DTO is null. For example, I want to throw a null pointer exception. All right, so here we need the new keyword, so a new null pointer exception, and here the student, for example, as a message, the student DTO is null. All right, so now we added a coverage to our method. So now let's go back to the test and make sure to readjust the test right here in order to make sure that this student method should throw a null pointer exception when we get a null DTO student. So we don't need this one since we don't have any assertions. And now let's just rename this method to make it more relevant. And here instead of should map, so let's say should throw and then a null pointer exception when student DTO is null. So now we have this mapper.toStudent, and then we are assigning it to a student. So we can also remove this assignment since we know that it will throw an exception and it will return nothing. So now how can I expect or make sure that this toStudent is going to throw a null pointer exception? So in order to do that, all I need to do, I need to assert that this method is going to throw a null pointer exception. So I'm just going to remove it. And now I'm going to use assert throws. So here, this throws method, first of all, it gets the expected type. So in our case, it's a null pointer exception dot class, and then it's a lambda expression. So here, when we call the mapper dot toStudent, I'm expecting to have a null pointer exception dot class thrown. So let's run this method and make sure that it passes green right now. So now this method is throwing this exception. So now what if I want to check the message that the message should be the student DTO is null or should not be null. So here, let's just rename it should not be null. And I'm gonna copy this message. And now I will go back here. So in order to do that, all I need to do, let's create a var message equals this. So as you can see, this assert throws, it will return the exception itself. All right, so now if I do msg dot, and here I have access to the method get message from the null pointer exception or from the exception, generally speaking. So now I want to do assert equals. I want this error message to be equal to my message or exception dot get message. So let's just rename this one to exp to say it's an exception. So exp for exception. And now if I run again, we need to be sure that the method threw this exactly the correct error message. So here, for example, if I add a dot and run again, the method should fail. And as you can see, now the method failed. And the assertion failure is we are expecting this, but we got this one. So in this case, we gained two things. The first one is that we add a coverage to our toStudent method, and then we also covered this within the test. So for example, in case I want to change from null pointer exception to a different exception, it will be automatically detected by this test method. Again, if I change, for example, the exception message, it will be also automatically detected. So now let me run it again and make it green. And now we added a new coverage to our method. So this is how you can test exceptions, and this is how you can catch exceptions and make sure, or you can do whatever you want. Even if you work with custom exceptions that you create your own, you can also capture that and do whatever you need to assert everything is as expected. All right, so now let's move on to the next part. All right, so we finished the implementation of the student mapper, and we saw how we can create a test class, how we can create test methods. Also, we saw how we can, or how much we need to cover our code, like we need to cover all the use cases. Now, let's move and start testing or writing tests for our student service. So we know that this student service is a Spring component, and it has a strong dependency with student mapper and the student repository. And especially when we talk about student repository, we talk about communicating with a database. So when it comes to testing, how can we test and how can we tell Spring or this student service that we have a student repository and this one needs to communicate with a database? And what happens in case we don't have a real database for testing? Because testing, it does not necessarily need to have a database for testing. So that's why we will talk about test isolation. So test isolation means that we want to run and to write tests for this student service in isolation of its dependencies. In a different way, I want to execute and write tests for this student service, but I don't necessarily need to have the real instance and the real object of my student repository. The same for my student mapper. So what do I need to do? I need to mock these two objects. So to do that, there is a framework called Mockito. So Mockito is a popular Java testing framework that helps you create mock objects and stub behaviors when writing unit tests. So it's especially useful when you want to isolate a specific component of your code and test it in isolation from its dependencies. So now we know what we need to do. We need to isolate and we need to mock. So you need to remember this term. We need to mock our objects. We need to mock the student repository and the student mapper to be able to run the student service test in an isolated way. So let's go ahead and let me show you how we can isolate and how we can mock the objects and the methods for each service that we have right here. So now, as always, the next step is we need to go and create a test class for our student service. So all I need to do, navigate here and then Command-Shift-T and create a new test. So here we don't need any of this. We just maybe need or use the setup method. So I will just check it out and then click on OK. So here we have our before each and we have our student service test class. So as we did for the student mapper, what we need to do here, first of all, which service that we want to test. So in this case, we want to test our student service. So I will create an object of student service and I will call it student service. And then when it comes to objects that have dependencies, let's check in here. So we see that our student service has two dependencies that we need to inject. All right. So our constructor is a constructor with parameter and it requires an object of type repository and an object of type student mapper. So let's just go ahead and do that. I'm just gonna copy this one and in here declare the dependencies. All right, I'm gonna paste this and then I will just fix the code. All right, so now I have my service and I have the dependencies. So what I need to do, so we said that in order to run this student service in an isolated way, what we need to do, we need to mock this student repository and the student mapper. So what we need to do, there is an annotation called mock. So this mock annotation comes from org.mockito. It's not the one coming from the org.spring framework. We want to use the mock from org.mockito. So let's select it one, and the same we need to add it to our student mapper. So in this way, we are telling our test class and the Mockito framework that we want to create mock for this repository and a mock for this student mapper. All right, now how can we tell this mocking framework that we want to inject these two properties and these two dependencies into this service right here? So the answer is kind of straightforward because I just mentioned injecting. So we have an annotation called inject mocks. So inject mocks always is coming from the org.mockito package. And like this, our mocking framework will try to find any dependencies annotated with the mock annotation that is compatible with the dependencies that are required from our student service. So this means when we try to create an instance or to initialize this student service, the mocking framework will look for two objects annotated with the mock annotation and that are of type. One of them is of type repository and the second one is of type student mapper. All right, so now we prepared everything. We still need to do one more step. So then what we need to do, we need to tell the Mockito framework that we want to open the mocks, or like we want to start the mocks for this current class. So this means that in the before each, here what we need to do, we need to use the Mockito annotations class dot open mocks, and this open mocks takes an object which is the test class, as you can see right here. So let's give it this because we want to open the mocks for the current class. All right, so you might see this warning right here. This is because the open mock methods return an auto closable. So, and this, the IntelliJ or your IDE will recommend to you that you might want to use a try with resource, but we can ignore that for the moment. It's not something really important or really gonna break our test. All right, so now we set up our test class. Now let's move on and implement the first test method that will allow us to save a student. So the first one, it will be this save student. That's good. Now let's analyze our save student. So we have here, first of all, we are doing a mapping and then saving the repository. And then again, we are doing a second mapping. So this is what we need to test in our test method. So let's go back to our student service test. And here I will create a public void and then should successfully save a student. All right, so this is our test method. Let's not forget the test annotation. And now here, let's remember the given, when, and then. So here, given what? So here in our save method, we have a student DTO. So let's first of all create a student DTO object. So let's go back here. And here I have, first of all, my student DTO object. Also, this class, it is going to need an object of type student, which is this one. So let's also go ahead and prepare our student. So it will be almost the same. So just copy the signature right here. And here I will create an object of type student. Let's call it student equals and then new student. All right, here, let's remove this one. All right, here we have also our student object and our student DTO. So what we want to do, or like how this is gonna work, this means is when we call our student service.saveStudent, we are expecting an object of type student response DTO. All right, so here I will create an object of type student response DTO. I will call it response DTO equals our student service dot save student, and then we have a DTO. So this is the DTO that we will pass as a parameter. And then what we need to do is to start asserting. So let's say assert equals, and then we have our DTO object dot get first name should be equal our response DTO dot get first name. All right, let's do the same also for the last name and also the email. So we can stick just to these few fields. We don't need to test everything. So this is what we want to test. So now if I run the test, what should happen? So let's go ahead and check together. So I will run this test method and let's see what will be the output. Here we see that we have a null pointer exception saying that we cannot invoke student response DTO dot get first name because the response DTO is null, and this is happening in here. So this means what? I'm gonna just add a breakpoint right here and I will run again this test in debug mode. So here, let's see our student service. So we have an object since it's already mocked. The same for our repository. So as you can see, we have a Mockito interceptor and so forth. So now if I evaluate this expression and then evaluate expression and then evaluate, we see that the result is null. Okay, so let me explain to you why we have this null result. So this null result is because the student service is trying to call the student mapper, and then we have the student repository is also going to call the save method. But remember, here we have a mock. So we don't have the real instance or the real service running for our test because we decided to run our student service in isolation mode. So to do that, what we need to do here, we need to mock the calls. So which calls that we need to mock? We need to mock every call that uses another service or another dependency in our student service. And in this case, we have the student mapper and we have the repository.save. So let me show you now how we can mock these calls. So the first thing that we need to mock is as you can see here, the first thing that we do is the mapping. So let's mock the mapping. All right, so now in order to mock the calls, so the first thing that we need to mock is our toStudent. So student mapper dot toStudent method. So this comes from Mockito. We have a static method called when. So this means when we call a method, so we have as a parameter the method to call. So here we have student mapper dot toStudent. So when we call this toStudent with our DTO object, so make sure that the mock will work only if we pass this object right here. So then what we want to do, then we have so many options. So we can return whether a student, we can also a student and a list of other students, we can return an answer, or we can even throw an exception. So in our case, we want to return an object, which is our student right here. So let's return the student. And now we are done with the first mock of our student mapper.toStudent method. So here when we say when, we are mocking a method, all right? So this, when we call the student mapper.toStudentDTO, then we need to return this student object. So this means that our student service will run in isolation mode, and it does not 100% depend on the real implementation, or the not the real implementation, but the real instance of the student mapper. So also let's import this in statically. So when student mapper, then return. All right, so let's do the same for our repository. So when our repository dot save and then student, then return our student itself. All right, because we know that when we save a student, we return another student. Or if you want to be more consistent, or if you want to have like more details, you can even create another student object. You can call it like saved student and set the ID and set everything, and also you can return that one. So let's just do it. It's totally fine. So I will call it saved student, and then I will just do saved student dot set ID, and let's give it the ID number 1. And in here, I will return our saved student. All right, so now we have 3 objects. So first we have the DTO, and then the student that will come from the mapping. And now this is the student that should be saved in the database. So now again, we mocked the second call, which is our repository. So if we go back in here, we still need to return another call. So here we need to mock also the student mapper dot to student response DTO. So in order to do that, just in the same way, so here we have when we call our student mapper dot to response DTO of our student object. Which one? Which is the saved student. All right. So here we have then return. Let's now just return a new student response DTO, and all we need to do is to pass the first name, last name, and email. So this is the first name, last name, and email. So let's just copy them from here. So we have our John Doe. I'm also going to inline this so you can see the full code, and the email is just john@email.com. All right, so now we have our test set and ready. So let's go ahead and run the test right now and see the output. So I'm just going to click and run this one, and let's see what will happen. So now our test is green. So we have all the expectations and everything was running in a successful way, because we have here, we mocked everything. And in case, for example, I just change anything, or you forget to mock a step, your test will fail. That's good. Now we created our first test method, and we saw how we can mock objects and also do some assertions. So this is the classic assertions. But now what if we ask the question, how can I check that my application is performing well? So here, for example, in this save student, I want to make sure that I only save one time the student into the database. This means, for example, I don't want to have some error or like someone typing 2 or 3 times this repository.save, because this will save the student many times. And in case, for example, you have a unique constraint, it might throw an exception and this will break the application. So let me show you how we can prevent this from happening. So if I go back to my student service right here, we can do this in the same place since we have our code already set up. All right, so here we are mocking. And now what I want to do, I want to make sure that this student mapper.toStudent was called only one time, same for the repository and the same for this one. All right, so to do that, Mockito also provides us with a method called verify, as you can see here. So we want to verify, and then we need to type the mock object. So our mock object is the class or the instance itself, and then we can pass a parameter. So it's a verification mode. So here we have a mockito.times. Also we have timeout. We have so many other options. I can, for example, check that a method call should take only, just as an example, should take only 2 seconds maximum to be executed. If it goes beyond 2 seconds, the test will fail. And like that, I can also make sure that I have performance issues with my application. All right, so now let's continue with these times. So I want to be sure that this student mapper dot to student, and then the object student DTO, or the DTO object that we created, it has been called only one time. All right, so let's do the same for repository, and then times 1, and then the save method when we pass the student object. Again, I will duplicate this one, and here student mapper, and then to response DTO, or to student response DTO, and here just to make sure that we passed the saved student as an object. All right, so here we need to say saved student. All right, I'm just going to align these methods right here, just so you can see everything. So here verify that this method, or these 3 methods of the different services, were called only one time. So let's go ahead and run the method again. So run this, and then the test passed. So now let's suppose, for example, that one of the developers, or me, for example, as a developer of this application, I accidentally forgot to remove this extra line. All right, so now if I rerun the test again, let's see what will happen. So the test will fail, and we will see here that wanted one time. So this means that we wanted to have our call only one time, but it was called 2 times. And here, so as you can see here, you have student service.saveStudent that was called 2 times. All right, and it was pointing to here and then to here. So here we see that even the test will point us directly where the issue has happened. All right, so that's good. Now let's move on, and let me give you a small exercise, and I'm pretty sure that you will be implementing it really easy without any issues. Now let me give you an exercise. I want you to implement the test for these find all students. So it needs to cover and to make sure that when you make a call to this repository.findAll, it should return the exact same list that you already expect. And in the next lecture, I will show you how to fix this one. All right, that's good. I'm sure that you correctly implemented the test for this find all student, but also let's go ahead and do it together. So I will create, as usual, a public void, and then I will call it should return all students. And then we have the given. So for the given, the first thing that we need to do is to create a list. So let's create a list of students. So this is the object that will be returned. So let's call it students equals new array list. And then let's add one student. So student.add, and we can even copy the student from the previous method right here. So I'm just gonna copy this one, and I will insert this student here. All right, so now we have one element in our student list, and then we need to mock the calls. So the first call that we need to mock is when we call our student repository, or the repository object dot find all. Then I need to return the students list that we created. All right, and then what we need to do, we need to mock the call for the mapping. All right, so here we have when mapper or student mapper dot to student response DTO, And here, since we might add or pass any student, so we can use the power of Mockito. And here we have argument matchers dot any. And here, when we say any, we can also specify the class. So when we receive any class of type student dot class, then I want to return, for example, a new object of type response, student response DTO, something like that. So I'm just gonna inline this. So when we call the student mapper dot to student response DTO passing any object of type student, we want to return this object. We can also make it more dynamic, but for the sake of a simple test case, it's also easy and it's also okay to make it like this. And here we just forgot the test annotation, so we need to add it. And now all we need to do is to have a list of type student response DTO, and then let's call it response DTOs equals our student service dot find all. All right, and here, so this is given, and now it's when we call this one, so then, so here we do assert equals that our students list dot size to be equal to our students DTOs dot size or response DTOs dot size. All right, so this is the implementation. Let's go ahead and run this method and make sure that everything is fine. All right, also should return all students is green. We can also add an extra test and make sure that, for example, this repository.findAll was called only once. So let's go ahead and test it just to make sure always that we have our application performing really well. So here we have our repository and then times 1 and then dot find all to be called only one time. Let's rerun again. All right, so the test is still green. So now let's move on and let me tell you what we will be doing next. All right, now I want to give you another exercise and I want you to implement the test for this find student by ID. I'm pretty sure you're gonna do it in a correct way and I will see you in the correction. All right, so as usual, let's go back to our student service test.java class. And the first thing that we need to do is adding this test annotation and then creating a public void. And let's call the method should find student by ID or should return student by ID. All right, so here always the given. And here we have an int student ID or an integer. Let's make it an integer. Student ID equals 1. And then let's create a student object. We can also take it from here. So let's call it student. So here we have student equals new student. And then we have when. So here we need to mock. So here we have when we call our repository.find by ID. And then we pass our student ID. And then I want to return an optional dot of my student. All right, and you might ask the question why I used optional, because this find by ID is going to return an optional. The second mock that we need to do, we need to mock the to student response DTO from the student mapper class and to return that one. So from that we can just copy this one. And then let's paste it in here. So here we have when we make a call to our student mapper, we are going to map this one. And again, we can just go up and copy these assertions. So here I will create an object of type student response DTO. I will call it DTO equals my student service dot find by ID. And then I will pass the student ID that I created. And now we have the then. So here we start the assertions. So here we have the DTO.firstName should be exactly the same one as the student.getFirstName. So here I will just copy the student from here and I will just replace it in here. So now we can select all and here we have get. And then let's make this one uppercase. And now that's it. Also, we can add another check. We want to verify that our repository has been called one time for the method find by ID. So passing also the student ID as an object, as a parameter. And now let's go ahead and run this new test method. All right, so we might miss something. Okay, so here expected john@example.com, but the actual was john.mail.com. So maybe let's fix it. So here we have mail. Let's change this one also to mail, and let's rerun again. And the test is green and fine. All right, so that was it for this method. Let's move on and implement the next one. That's good. You really made a really good progress, and I'm really proud of you. So the next method that we need to implement the test for is find student by name. And just I want to give you a quick hint. You can inspire from the previously implemented methods in order to implement it in a correct way. So take your time, and I will see you in the next lecture to provide you the solution for this exercise. All right, you did a good job. Now let's correct this exercise together, and you might learn something new. So as always, we need to add the test annotation, and then we have a public void, and let's call the method should find student by name. All right, so then what we need to do, the first thing, we can also copy things from what we have before. So I'm gonna explain it one by one. So we can copy this part right here. We can also copy this one right here. So here we copied. So also let's copy it with the given. So here the initialization of the students list, and then we have the mock for the find all. This one we will change later on. And also we need to copy the mapping. So let's go back here. And now, so when we call the find student by first name containing, and here I just need also to declare a string student name. Let's call it John. All right, so here containing student name, then return the students list. And then when we call the student mapper.toStudent response DTO of any student object, I want also to return this mapped object or the student response DTO. Now, when I call, so here let's use a var just to make it shorter. I will call it response DTO equals our service dot find all by name. And here I need to pass the student name. So then I need to do some assertions. So I want to do assert equals that the students dot size is equals to our response DTO dot size. So this is what we need to do, or what we need to check. Also, we can add a verify that our repository has been called one time for the method find all by first name containing our student name. So I'm gonna break the line for this one. And now let's run the test and check the result. All right, so the test is green and our method is correctly implemented. All right, that's good. So now we still have only one method in our student service. So let's go ahead and create an exercise for that. And also we will see the solution together. That was it for today's video. I hope you learned how to test your applications, how to test your services, how to mock, and how to avoid injecting real Spring Boot services and dependencies into your test classes. So what I want to ask you now, hit the subscribe button, smash the like button, and help this video and help me grow this channel to reach more and more people. And also, the most important thing, stay tuned for the next video, because it's a real game changer and it will be something that you really like. I've been working for months on this video and now it's ready to be released. Thank you so much and see you next time.